Welcome to homework.
So with n, this is a simple graph with n vertices and an edge between every pair of vertices. So an example of this would be something uh, like this. And what we know is that because there is an edge from every vertex to the other vertices, if you have, say, n vertices, that means that there will always be, this is n vertices right here. That means that there will always be n minus 1 edges. And because that's the case, um, because an Euler path has two vertices that are an odd degree, keep in mind that no matter what number you plug in here for n, um, if you plug in an odd number, then you have an odd number of vertices. If you plug in an even number, then you get an odd degree. So because only two vertices can have an odd degree, that tells us that n has to equal 2. So that ensures that you have that odd degree. But it couldn't be, say, 4, because then you have multiple vertices with an odd degree. So n equals 2 for k of n. Then for c of n, this is one that has n vertices, and it also has edges connecting, say, v1 to v2, v2 to v3, v3 to v4, and so forth. So there is an edge from every vertex to two other vertices. So the degree of every vertex is 2. And we also realize that the very last one, Vn, is going to connect back to V1. So eventually it'll create a loop. So because they all have an even degree, that means that there is no value of n that allows for an Euler path. It would just be an Euler circuit. Then we have Wn, which is a wheel, and that is a cycle, which is Cn, but it has an additional vertex connected to all of the other vertices. So since the degree of each vertex was 2 in part B, that means that all the vertices will have degree 3. And because of that, there's only going to be an Euler path when two of the vertices have an odd degree. So that means that Wn cannot have an Euler path because they would all have, many of them, multiple ones would have a degree of 3, more than just 2 in that case. Then we have Qn. So with Qn, this one has n vertices, and there's an edge between the two. It's all, they have bit strings. So if the bit string S has length n, then there are n strings that differ by exactly 1 bit from S. So the degree of S would be n. And because there can only be two vertices that have an odd degree, that tells us that if n is odd, there must be only two vertices with an odd degree. So that means that all we can have is one vertex. So that way the bit strings are length 0 and 1. So in this case, n is equal to 1.